Namaskar. Welcome to the channel Anka Ananda Aharan, that is extracting happiness from the teaching learning process of mathematics. Today we will discuss orthogonality. That is chapter 3 of Linear Algebra and its Application by Gilbert Strang book. Here some of the problems from the exercise are being done. And in this video we will see that the documents contain 50% typed and 50% handwritten. Already I have solved those problems, just I will explain in this video. Why either I should have done everything handwritten or everything typed. Why I have done this? Because it is being found that some of the PDFs that are being used by the students of this institute, they are wrongly written. And even if I tell it several times that it is incorrect, in fact there are several blunders also in some of the results. So to make the student feel that here there was a mistake or there is a mistake, I have kept the partial half part of the question up to which it is correct I have kept, and after that where rectification is required, there I have done handwritten intentionally. So let us discuss. These are the questions which pairs are orthogonal among the vectors v1, v2, v3, v4. Here v1 transpose v2 is equal to what? This is v1 transpose v2 is equal to 1 into 4 plus 2 into 0 plus minus 2 into 4 plus 1 into 0. 1 into 0. That means this two are 0, it is minus 4. So it is non-zero. Similarly, v1 into v3, these two vectors. First component 1, second component minus 2, third component plus 2, fourth component minus 1. So they are cancelling each other, it is 0. Next, this is v1, v4, this and this. So how much will do? All are 1 here, so I will add the components of v1. 1 plus 2 minus 2 plus 1, it is 0. v2, v3, some mistake. Plus 1 plus 1, how it is? It is 2. So these two cancel each other, but it is 2. It is non-zero. Now v2, v3, these two. It is 4 plus 0 minus 4 plus 0. That is 0. So this is orthogonal and these two vectors are orthogonal. Now v2, v4. v2, v4. All are 1. So just we have to add the components 4 plus 0 plus 4 plus 0. It is 8, which is not equal to 0. Then v3, v4. Again addition. That is equal to minus 2, which is non-zero. So these are the all possible orthogonal pairs. So what are the pairs? So v1, v2 and v1, v3 and v2, v3 are the orthogonal pairs. Rest all vectors are not orthogonal to each other. Next question is find the length and inner product of x and y. X is this, so length of x is nothing but 1 square plus 4 square plus 0 square plus 2 square whole root over each component square. So it is 21. And y, what about y now? It is 2 square plus minus 2 square plus 1 plus 3. Again value is 18. Now inner product of x and y. This is 1 into 2 plus 4 into minus 2 plus 0 into 1 plus 2 into 3. That is how much it is? 6 plus 2, 8 minus 8, 0. So this is written here. That means the two vectors are orthogonal to each other. Next question is, find a basis for the orthogonal complement row space of A. First of all, what is orthogonal complement of row space? It is null space. That means we are interested to find a basis of null space of A. Next part of the question is, split x is into x333 into a row space component xr and a null space component xn. Let us do it. This is basis for the orthogonal complement of the row space of A is same as the basis for the null space. That is, as orthogonal complement of row space is orthogonal complement of row space is the null space. So what is the null space basis? So to find out the null space basis, here we should go for the echelon form, that is R2 minus, to find out the null space basis, what we used to do, R2 minus 2R1 stored in R2. That is 102, and this is subtracted, it is 1, it is 2. So the third variable is the free variable. First variable and second variable are having pivots. So this into UVW is equal to 0, 0. So here third variable is free. So there I will assign value 1. Now substituting this value, what I am getting in this equation? What I am getting? This is the first equation. W value I have substituted. So I will get its value is minus 2. Now again substituting value here, W value here in this equation. That is, from the first equation we got this, and from the second equation we got again minus 2. So the solution is minus 2, 1. Now persons, what they are doing in the part which I have cancelled or cut from the video, from this PDF, is just 333 from the vector 333. Persons are subtracting the vector minus 2, 1, and the resultant 552 they are writing as row space vector. No, it is not a row space vector. There exists no combination which represents 552 from these two vectors. From these two vectors linear combination, I cannot get this vector. Hence it is incorrect. So what I have to show a row vector means either I have to prove that it is a linear combination of rows of A, or I have to take any row of A. So here directly I have taken a row of A. What is it? It is 333. This second row we have considered. Naturally it always belongs to the row space. So it is 114 plus minus times this vector, that is 2, 2, minus 1. As the NA, null space, is a vector space, so scalar multiplication property is satisfied by N of A. So if minus 2, 1 belongs to null space, then 2 to minus 1 also belongs to the null space. Hence, this is the second row of A, and this is null space, negative times the basis vector. So both of them, it is from row space, it is from null space. Hence, this belongs to, this is the required target. It is my x. X I have written in this way. So it is correct. Now, so that x minus y is orthogonal to x plus y if and only if x is equal to y. So x minus y is orthogonal, that implies inner product with x minus y and x plus y is equal to 0. That implies and implied by the transpose is taken here, whole transpose is taken individually. Then that implies and implied by individually multiplication we have done. Then what we are getting, observe here, this and this. Array, here it is a mistake. So this line is incorrect. I have not seen it. So this is equal to, this is equivalent to, let me write down again, x transpose x minus y transpose x plus x transpose y minus y transpose y is equal to 0. So these two vectors are having, these two values, vectors mean values are same but opposite sign, so they cancel each other. Then we will get only x transpose x minus y transpose y is equal to 0. But x transpose x is representing square of length of x, that is norm of x, minus it is square of norm of y, hence that value is 0. So which implies x taking, since norm of x and norm of y both are non-negative, so they imply this. Since norm x and norm y are non-negative values, hence we got this conclusion. Finally, we started with x minus y is orthogonal to x plus y. We got it implies and implied by length of x square, x is equal to length of y. Hence it is proved. Okay, next part of the question is, given any two positive numbers x and y, choose the vector b equal to root x comma root y, a is equal to root y comma root x. Apply the squared inequality to compare the arithmetic mean, that is half of x plus y, with the geometric mean root over xy. So here this is my a, this is my b. So what is my a dot b? Clearly a transpose b is equal to root y root x plus root x root y, that is 2 root over xy. And what about length of x? Length of a is root y square, root y square, clear root y whole square plus root x whole square, its root over. It is my length of A. Similarly, what is my length of B? Length of B is equal to root over x whole square plus root over y whole square. So now by Squarge inequality, what we are having now, by Squarge inequality we have mod of A transpose B is less equal to norm of A into norm of B, which implies we have substituted the value, it is this line. That implies, again taking the half that side, root over xy is less equal to, this x plus y is equal to y plus x, and root over they give us x plus y by 2. That is arithmetic mean, and previous was geometric mean. So geometric mean is less equal to arithmetic mean. Hence proved. Now let us discuss the second part of the question. Using the triangle inequality, x plus y norm is less equal to norm x plus norm y, reduced to Squarge inequality. From this we have to reduce the Squarge inequality. So this is our triangle inequality. Now taking square on both sides, we got this line. We know square of norm of something is equal to x transpose square of norm of x, that is equal to x inner product with itself. So this is square of norm of x plus y, that is x plus y inner product with xy. Now this side, it is x square plus 2xy plus y square. Now that implies what? So here this implies that the transpose taken inside and it is simplified. Finally what we are getting? X transpose x, x transpose y, y transpose x, y transpose y. So here this as x transpose y is equal to y transpose x, this I can write as 2 into x transpose y. So now from the both side, if I cancel, what I will do, these things I will cancel. What is left with me, I will cancel these terms from both sides. And finally we got it is x transpose y. It is actually, even if it is positive, this is true. Even if it is negative, it is true. That's why, because it is the right side is positive here, but naturally it is always positive. So if it is magnitude is also taken, Sometimes this is scalar, this quantity is a negative quantity. If it is negative, there is no question of no confusion, directly it is less than. But even if it is positive, in that case also it will hold true. So that's why this x transpose y, if we are taking the mod, still it is less than that. So this is our required result. Now, by choosing correct B in the square inequality, prove that this. Let A is equal to the given A1 to N and B is equal to 1, 1, 1, N number of ones. Then we have the square inequality as mod of A transpose B is less equal to norm of A into norm of B. Taking square on both sides, it is mod of A square of mod of A transpose B is less equal to length A square into length B square. But left hand side, as B is equal to B1, B2, B3 all are 1. So it is A1 plus A2 plus and so on up to AN whole square is less equal to, it is the length of A square, it is the length of B square. When we add all these n number of ones, we get n. So this is our required target achieved. Now prove that trace of the matrix A transpose by A transpose A, which is the sum of the diagonal entries, is always 1. Let this be A. Naturally, we know project matrix P is equal to A transpose by A transpose A. Now A that is, this vector is A, it is A transpose. When they are multiplied together, we get this matrix, and the denominator is nothing but square of length of A. Now we know that if any scalar is multiplied to a matrix, then it is multiplied to each element of the matrix. So here this 1 by A square is taken out, but it is assumed that each element is having this number as in its denominator. So I have taken outside. Now what about the diagonal element sum? The diagonal element sum is A1 square by norm of A square, A2 square by norm of A square. So likewise, every term is divided by this, and that I have taken common. So it is A1 square plus A2 square and so on up to AN square. So here this is nothing but whole A square. Length of A square, that is length of A square by length of A square is equal to 1. Hence we have proved that trace of P is equal to 1. Next question, project the vector B along A. Here find the projection vector. Here we have B is equal to cos theta sin theta, A is equal to 1, 0, and we know P is equal to the projection vector is equal to A x cap or x cap A, which is equal to, where x cap, what is the formula for x cap? X cap is A transpose B by A transpose A. Here A transpose B means 1 into cos theta plus 0 into sin theta, that is cos theta plus 0. And what about A transpose A? 1 square plus 0 square, that is 1. So finally the scalar x cap is cos theta. And projection vector P is equal to x cap A, that is cos theta into the vector A 1, 0, that is equal to cos theta into 0. That is equal to the vector cos theta 0. Sorry, I have pronounced something wrong, which is a blunder, but this is cos theta 0, the vector. Now solve Ax is equal to B by least squares and find P is equal to Ax cap. Here A is given 101, 011, and B is given, that is 110. verify the error B minus P is perpendicular to columns of A. So here nothing much to be done, just for a repetition we have done this in case of while discussing this orthogonality chapter, that is orthogonal projection onto column space of A, we have discussed this example. So here once again we are revising. It is x cap is equal to A transpose A whole inverse into A transpose B. In this formula we will substitute A and value of A and value of B to get finally A transpose A is equal to this much and A transpose A inverse is equal to this much. Then x cap is equal to, putting all these values in the formula, 1 by 3, 1 by 3. Then we have P is equal to A x cap. So we got my P, I got my P is equal to this much. Hence, what we got? We got P, we have B, and error is B minus P. Hence, this is the error. That is 2 by 3, 2 by 3, minus 2 by 3. Now, columns of A are A1 is equal to 1, 0, 1. Columns of second A2 is 0, 1, 1. So, there A1 E transpose E, that is inner product with E of A1 is giving me this 2 by 3, 0, minus 2 by 3. So again it is giving 0. Similarly, A2 transpose E is equal to 0, 2 by 3 minus 2 by 3. So both case we got 0. Hence E is perpendicular to columns of A, that is E is perpendicular to column space of A. Hence the target is achieved. Now the question is, the following system of equation has no solution. Ax is equal to Ax is equal to B. Here A is given, B is given, and this is A, this is X, this is B. But as it has no solution, there exists no exact X for which Ax is equal to B. There is a gap. And that gap will give us the error. And our target is to find out the least of square of the length of the error. Now here Ax cap. So because X does not exist, we will find out approximate solution, that is Ax cap. Now Ax cap minus B is equal to the error which is having values. So this vector I have multiplied. So first column vector is multiplied with C, second column is multiplied with D, and it is this B vector taken that side. Finally we got C minus D minus 4, C minus 5, and C plus D minus 9. This is our error vector. If this is the error vector, what is the length of the square of the error? So what is the square of the length of the error? It is this one, each component's squares sum. Now for what value of C and D it will be least, that is to be obtained. We know from calculus that if any values, extreme value, maximum or minimum value are to be obtained, its first order derivative becomes 0 there. So here the unknown variables are C and D. We will differentiate E square, length of E square of length of E partially with respect to C and partially with respect to D. We will equate them to 0 and we will get two equations solving which we will get two values. That is one value for C, another value for D. So once I got my C and D, I should substitute there in the equation y is equal to C plus dt. The equation fitting the straight line is y is equal to C plus dt. Here in this formula, we have to substitute the value of C and D to get this equation. Already this is my x cap. Now as this is my x cap, projection of B onto C of A is Ax cap. So this is my A, this is my x cap. Finally, this is my projection vector. Okay. So I hope there is no confusion. Just it is simple calculation. Put the formula, get the answer. Find the projection of B onto column space of A. Here A is this columns, matrix A is the matrix and B is this. We are interested to find out the projection. That formula is, this one is the formula. And next part is split B into P plus Q, with P in the column space, Q in the perpendicular to that space. Which of the four subspaces contain Q? Now what we are getting? So it is the projection vector formula. It is A inverse of A transpose A into A transpose B. So here this is the A transpose B, it is A transpose A, it is inverse of it. So that is 1 by 22. Finally this one is the inverse. Substituting all those values, we got our x cap this much. So once our x cap is there with us, so P is a x cap. So here this is x cap, the scalar quantity I have taken outside. So this is my A, this is my P. Finally we are getting this as the projection P. It is x cap. So finally projection P is, this one is the projection P. Calculations can be verified. It is always subjected to error. So that's why one should not depend on these values. These are the methods. So we can do our own calculation as per the problem's need. Now we have got P, we have B, and we have one information that B is equal to P plus Q. Naturally, if B is equal to P plus Q, Q is equal to B minus P. But we know that B minus P is nothing but error, and error is always orthogonal to the column space, that is it is belonging to the left null space. So here this Q belongs to the left null space. Now let us substitute the value. It is the value of B, it is value of P, it is value of Q. So this is my A transpose, it is Q. A transpose Q, after multiplication we got 0. Hence what is our conclusion? A transpose Q is equal to 0, that is Q belongs to left null space of A, that is Q is orthogonal to column space of A. Hence Q is a vector orthogonal to the column space of A, that is Q belongs to the left null space of A. So this part of the question is over. Next is best fit straight line by least square methods to the given measurement. So here this is B1, this is T1, that is for T1 is equal to -2, B is equal to 4, for T2 it is -1, B is equal to 3. So this is T1, T2, T3, T4. This is B1, B2, B3, B4. Okay, and our straight line, which is best fit straight line, is y is equal to c plus dt. So that is when we are writing this equation, what it is? It is y1 mane b1. It is, the equations are, we are writing it as ti is equal to bi. So for every value t1, t2, t3, t4, the equation becomes the coefficient observed. Here c and d are unknowns, and coefficient of c in every equation is 1, so that's why the first column is 1. It can be written in 4 equations, that is c plus dt1 is equal to b1, c plus dt2 is equal to b2, c plus d of t1 t3 is equal to b3, c of d into t4 is equal to b4. So likewise from 4, so these are the t1, t2, t3, t4. So is equal to this into cd, this is my A, this into cd is equal to my B. So here we are interested to find out CD, to substitute. And as we know that it is fitting a straight line, and the formula for fitting a straight line is already known to us, we need not worry about the intermediate steps. Directly we can apply the formula. This formula is with us when we are interested to fit a straight line to given data. In this case only this method is applicable. So here the C and D, x cap is equal to C and D, A x is equal to B. To this data we want to fit. That means we have set of data Ti, another set of data Bi, and how many number of equations? M number of equations are considered. In that case, x cap is equal to M, that is number of equations, that is all these ones are added, M times, it is giving M. Sum over Ti, I is equal to 1 to M, I is equal to 1 to M, I is equal to 1 to M. It is I is equal to 1 to M. It is also I is equal to 1 to M. Total M number of equations are given to us. So that's why everywhere we are adding up to 1 to M. So we got all these values. Now this column values we have added, it is giving me M is equal to 4. And this minus 2, minus 1, 0, plus 2. They cancel everything and minus 1 remains. So sum over Ti is equal to minus 1. Similarly, sum over Ti square in this equation, 4 plus 1 plus 0 plus 4, that is 9. So here it is my sum over Ti square. Next is sum over Bi. What are the components of B? It is 4 plus 3 plus 1 plus 0, that is 8. Sum over Bi is 8. Sum over Ti Bi 8 minus 8 minus 3 minus 11, rest were 0. So 8 minus 11. Yes, this is 8 and this is minus 11. Now after simplifying and calculating all other values, we got our x cap is equal to this much. So this is my value of C, this is my value of D. Substituting, we got our Y. And once we got our Y, next part of the question is project B onto C of A. We got our C and D, that means we got our x cap. And we have the formula P is equal to Ax cap. So this is A. This 1 by 35 into this matrix is our x cap. So Ax cap is equal to P, which is the required value, this. Hence, we got the projection of B onto column space of A. I hope the concepts are clearly understood to all the viewers. Regarding the values, it is better to rely on the own calculations. Thank you for your patient listening.